Hello and welcome to another video. In this one, we're going to talk about what's new in Python 3.10. At the moment, 3.10 has just entered the beta freeze, which usually means there's no more features. So hopefully this represents what Python 3.10 actually ships with. But if not, I'll edit the description for anything that changes. But anyway, let's jump into it. So this is kind of going to be like a top 10-ish. However, I actually have like 12 or 13 things, so it's close enough. But anyway, let's get started. I'm going to be using, again, as I said, Python 3.10 version. We're using 3.10 beta 1, and this is from Dead Snakes, which I build, so that's how I have Python 3.10 already. All right, and basically what I did for this is I went down the what's new in Python 3.10 and picked out the things that I thought were the most interesting. These, I can't possibly cover all of it in one video because it's a huge amount of work went into Python 3.10. But I'm going to just cover the stuff that I think is the coolest or the most important. All right, and the first thing that we're going to get started with is the syntax changes. And the first, and I guess the big major one that is perhaps the one that people are most excited about, I'm not really excited about it, but that's just me, is the match statement. And I already did a video on the match statement, so I will link that in the description, but I just want to show you a small example to get started with the match statement, just so you can kind of see what it's about. And yeah, it implements what's called structural pattern matching. It's kind of like a switch statement, but not at all like a switch statement. So you can think of it like a switch statement, but it's really not. So let's say we have, oh God, I almost wrote JavaScript for a second. Let's say we have an assignment, and my text editor is not going to highlight this because things have not caught up with that yet. You write a match block, and inside the match block, you have a series of case statements, and those case statements will attempt to match the inputs to the match statement. So we can say, like, case 1, it was 1, case 5, it was 5, and it was not matched, for example. And if we run that 3.10 t.py, you'll see that it was 5. And the reason it's called structural pattern matching is you can use structures to match things. Let's actually do 2.5. It started, we should assign to a different variable. Started with 1 and had y, for example. And if we copy this again, let's say we started with 2 and it had this. And so in this case, we are making a pattern here that says it must be a sequence that's length 2, and the first item has to be a 2, and we will capture the other variable into y. Of course, it's way more complicated than that. So I would suggest watching the other video that I did on this, which will go into all of the details about all the different things you can do with the match statement. But anyway, that's the match statement. So a new statement that is in the language. All right, the next thing that we're going to talk about is parenthesized context managers. I wrote this wrong in my notes, but you don't get to see my notes. That's fine. So what this means is we can finally have multi-with statements with implicit continuation, no more ugly backslashes, and none of that stuff. Technically, this was in Python 3.9, but it's also in 3.10 and finalized and official now. To give you an explanation of what I'm talking about, import context load. We're going to make a context manager, just a very simple one, and kind of show you what you would have to write before and what you no longer have to write now. So it's just a very simple context manager where if you do with ctx as x print x, and you can see, works fine like that. If you had multiple of these, you could join them with a comma, and this would work fine as long as you were on one line of code. So that worked fine, x and y. But if you imagine that this was a very, very long name, or you had a very, very long name for your as, or you had a very long number of these, you would have to split them across multiple lines. And I honestly never found a really good way to write these. This is how I used to do it to kind of like make it not look so bad. But it still looks pretty bad. You have, a bunch of backslashes. You have a comma that's different on one of these, so if you need to add another one, you don't get nice trailing commas. But this, this works in previous versions of the language as well. So this is what you used to have to do. But now in Python 3.10, you can instead replace these backslashes with parentheses. And this comes about because, Python 3.10, of course, it doesn't work in 3.8 because that's not a thing. And you can have glorious trailing commas there, which is really nice as well. I've wanted this for so long. Ever since Python 2.7 introduced multi-width statements, I've been like, well, it would be really nice if we could put parens around them. But it turns out the way the parser was set up before 3.9 and 3.10, the parser would not support writing context managers like that. But yes, multi-widths, I'm really excited about this. I think this is really cool. All right, the next one is that a lot of error messages have been improved. And in fact, I actually contributed to this one in 2 ways. One is I complained about it on Twitter, and then the release manager was like, oh, we could do that, and then just spent a bunch of work improving error messages. And the other is I actually contributed one improved error message as well in an error message that you'll never ever see, but it's fine. Let me show you some examples of those, and a lot of this is inspired by the work that PyPy did. So I'll give you an example of an error message that was pretty bad before. So if you have an unterminated function call, so something like this, and you call this in 3.8, you'll get kind of this weird syntax error, unexpected EOF while parsing, and points at line 4, which my file is only 3 lines long, so there is no line 4. And it's just kind of hard to know what's going on there. And PyPy has had improved error messages in this domain for a very long time. So PyPy actually tells you, oh, you have an unfinished parenthesis here, a parenthesis. So you should close that. And in Python 3.10, it now does the same. So you can see that Python 3.10 also has has similar improved error messages. Now the messages aren't exactly the same, but they're improved. And there's a whole bunch of examples in the what's new. So you can see invalid syntax points to the right line, never closed, generator must be parenthesized. Oh, this is neat though. I like this, where it points at the whole generator. Really good. But yeah, there's a whole bunch of examples of that in the what's new, so I'm not going to go over all of them, but know that this was pulled from PyPy and made a lot of improvements there. All right, and there's one other minor syntax change, but it's not even really worth mentioning. You can now remove parentheses in assignment expressions inside set literals or something like that. It's so minor that I don't think I'm not excited about it. I don't really care. Well, one, I don't really use the walrus operator, but also, yeah. All right, so that's kind of the end of our syntax changes. Everything from here on out is either library changes or built-in changes. I think we'll start with the typing stuff first. So if you're dealing with type annotations, this stuff should excite you. Otherwise, you probably don't care. The first, and the one that I'm the most excited about all of the typing changes, is in Python 3.10, there is now a built-in union syntax. So before, what you had to do is you had to do from typing import union, and then you would have to do union and comma stir, and pretty verbose and a lot to write out for this. But in Python 3.10, you can now do int pipe stir, and this will give you a special union type, which is now a built-in type, and it acts the same. Well, it acts mostly the same as typing union. There's, of course, some teeny tiny differences because of the way typing is implemented, but yeah, you can now use pipes in your type definitions. And if you're using MyPy, you can actually use this syntax in older versions if you use from future import annotations. So you can use this all the way back to Python 3.7 if you're on a modern enough version of MyPy. But this saves, a lot of typing, but also an import in pretty much all the code that I write. So I'm super happy about this. This is really cool. All right, the next typing change is ParamSpec. Which there's a whole pep that goes over this. Let's see if they have the example here. Yeah, there's an example here. So what ParamSpec allows you to do is have forwarding of argument specifications. And if you've ever tried to type a decorator, you'll you'll realize just how much of a pain it is to write typing for a decorator and do it correctly, even if you're just maintaining the exact signature of the original function. But if you go about changing the signature, it's way trickier. But what parenthesized is, it's kind of a specialized type variable, and it allows you to represent the call shape of a particular function, such that you can write a decorator that forwards its call shape. So you can see here, this is a trivial decorator that maintains the same call shape. There's also this concatenate, which allows you to add to the call signature. So in this case, this adds a lock parameter as the first parameter in this call structure. So it allows you to kind of change the signature of your function. But this is super useful if you're writing decorators. Without call spec or without paramspec and concatenate, it's really difficult to write decorators correctly in typing. So I'm excited to start using this. I also have two honorable mentions. They're less interesting in my mind, but they are brand new things, and those are TypeAlias. And what TypeAlias lets you do is you could before today you could have aliases in your typed code, and I did a video on type aliases, so I will link that. I guess I'll have to update that now that this is a thing. But you couldn't have forward definitions or quoted type aliases because the type checker couldn't tell the difference between, just a normal string constant and a type alias. So type alias now is an explicit way to tell the type checker, yes, treat this as an alias, don't treat this as a constant. So little teeny tweak there, but pretty nice. The other thing is type guards, and these they didn't even get a blurb here, but basically TypeGuard is a way that you can write your own functions that narrow the type of something. So you can say, instead of always having to rely on like isInstance to narrow the type, you can have a custom one that does it that way. And I think there's a whole pep that goes over the bits here, but here's the actual TypeGuard. Oh, those are just examples. Here we go. So this is something that, this is a function which, given a predicate, it takes in a list of unknown things and says, everything in that list must be strings. And this is a Boolean, sort of a Boolean subclass, but it allows a type checker to be smarter about the rest of a function, basically. That's what TypeGuard does for you. There's a couple other small changes to typing, but I think those are the most important ones. The next thing that we're going to call out, this is actually pretty minor, but it's a question that gets asked a lot in interviews, and so I think it's kind of cute that Python will now have a much shorter answer to this problem. So a question that gets asked in interviews a lot is, especially like very early interviews or C interviews or whatever, is write a function which counts the number of bits in an integer. And if you have a number and you want to know the bit count, basically the way you do the interview question is the easiest way is you AND with the lowest bit, and if it's 1, you add 1. And then you shift, and you AND and shift, and 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 shift. There are, of course, faster ways to do bit count, but that's how I would do it in an interview. But there is now a, gotta parenthesize this, I think. There's now a bit count method, count, on integers in Python, so you can just get the bit count directly, which is, I don't know, kind of neat. The next thing we're going to talk about is the mapping views, so keys, items, and values in dictionaries. So dct equals 1, 2, 3, 4. So if you do dct.keys, this gives you a keys view. This necessarily has to have a reference back to the original dictionary such that it can show you the keys there. But there wasn't a way to access the original dictionary from that. And so now there is a dot mapping attribute on the views here, so keys, values, and items, which allows you to re-access the original dictionary. I don't really know when this is going to be useful, but I don't know. It at least makes the reference back explicit. And note this is a mapping proxy, so it's not mutable, it's an immutable view of the original object. So it's still maintaining the immutability of these objects. You can't just like reach into the original dictionary and modify it. But it it does give you a reference back there. Another thing that's really cool are some of the new attributes that have been added to the sys module. So one of them is sys.builtin. Oh wait, standard lib modules names. That's what it is. Standard lib module names. There was always built-in module names, which was kind of misleading. Sys.built-in module names. These are all the modules that were compiled into the Python binary itself, and not actually the list of all of the standard library modules. But there is now a standard lib module names. This will be mostly useful for static analysis tools that need to say like, this is a first-party import versus a third-party import or something like that, or this is a standard lib import. And so you can see a list of all of the modules in here. There are, of course, a few that are left out. Like I think some of the Easter egg ones are left out, so double under hello is not listed in sys.standardlib module names, but it is a standard lib module. So there are some exceptions to this, so it's not 100% accurate, but it's it's as good as you probably would want it to be. So that's new. The other thing that's new, and this is actually pretty cool, is sys.originalArgv. So Python, as part of Python's startup, it actually modifies what the argv looks like. And sys.originalArgv can help you figure out how the program was called. So let's actually import sys, and we're going to print both sys.argv and sys.originalArgv and kind of compare the two and show you why those are different and why you would want to care about this. So if you run this, we need 3.10, of course. You'll see that sys.argv eliminates the Python executable, so it's sometimes harder to figure out how it was called. Also, it will change how it's run if you like run it as a module, for example. So if you do -mt, you can see that sys.argv gets changed just to the file name, so you don't even know that you're called with -m, but it might actually be called with -m. And this is like, man, I wish this existed like, I don't know, 5 or 6 years ago, because I was writing a re-execution daemon thing where basically, after some amount of time of running, it wanted to restart itself and basically rerun the same program. And it was really hard to know like how to re-exec yourself, because you didn't know whether you were called as a file name or whether you were called with -m or all sorts of different things. And like figuring out the directory structure and all sorts of stuff to kind of simulate the original call was hard. But now you can just get it directly out of sys.originalArgv, which is pretty cool. All right, so the next one we're going to talk about, I always have to include at least one thing that I worked on. So we'll include the one thing that I worked on. It actually didn't get called out in the What's New docs, but whatever, I don't care. And that is that the tokenize module, so the pure Python tokenizer, is somewhere between 20 and 30% faster. And this has huge impact on linting and code formatting tools that need to run the tokenization. So this will speed up a lot of tools in the ecosystem that I care about, linters and code formatters, by making tokenize a lot faster. And this ended up being like a really simple patch. I actually did a video on this particular change, so I will try and remember to link that in the description as well. But the TLDR is it was really just a one-line change and a lot of conversation. But it makes tokenize way faster and makes linters way faster. Beyond that, I have a few other honorable mentions that I wanted to call out. So the first is there's two, well, I think there's only two new built-ins. There's anext. Oops, of course we need to be in 3.10. There's anext and aiter. These are equivalents, async equivalents of the next and iter built-ins. So new async support for built-ins. These were kind of clunky to write before because you had to essentially do, you had to call aiter or .anext on stuff directly, and like that was kind of gross, so they added built-ins for those. The other one that's really cool is there is a strict keyword argument for zip. So let me show you. Let's say we have list 1 equals 1, 2, 3, and this is a common mistake that's made in Python. 1, 2, 3, 4, 5. 4xy in zip, list 1, list 2, x equals and y equals. Yeah, so this is a common mistake in Python. Zip by default will stop once one of the sequences has been exhausted. So in this case, like, because list 1 was shorter than list 2, it just stops here. Which sometimes you don't want that. Like, really, in my mind, it should be an error if you're trying to zip two things that are not the same length. And other people had that same thought, and so there's now a strict equals true option to zip, and that will produce an error that says argument 2 is longer than argument 1. So it allows you to kind of short circuit this bug. I wonder what it does for iterables. I don't know how it could do it. Like it must error when it gets to the part? I'm not sure. Yeah, it errors when it, okay. So it still does some of the iteration before it does. So it tries a length check at the beginning and then, iterates forward and then will produce an error. But I think this is, really helpful and like something that was, missing, and an easy foot gun that now has a solution with this keyword argument. But anyway, that's kind of my top 10-ish of things that I'm interested about in Python 3.10. You, of course, can check out the What's New in Python 3.10 document and figure out the other stuff for yourself. But anyway, hopefully this was interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.